Alright, the goal of this video is to walk you through the important parts of the things we've learned so far in this chapter. We'll start with prisms and cylinders. They both behave the same way. The goal of these shapes is to first of all identify the base. The base is the shape that's parallel and opposite itself in the three-dimensional figure. So here we have a circle. This one's a triangle. Sometimes you might have what are called complex bases, which are made up of different kinds of shapes, in this case two rectangles possibly, or a rectangle with a rectangle cut out, sectors, and also possibly polygons. Whatever the shape might be, the goal of those shapes is to find the area of that base and the perimeter of that base and the height of the prism. Again, the height of the prism is how far those two bases are apart. This distance right here would be your height, this distance right here would be your height, and this distance right here would be your height. Whatever the shape's area of the base, perimeter, and height is, you use these formulas that all use those same pieces, and you can find your answers to the questions. Alright, now let's move on to scale factors of similar figures that deal with the linear ratio, the area ratio, and the volume ratio. When working with these questions, you're going to need to solve this with a proportion. When you set up your proportions, make sure you understand what your fractions are being made out of. The 3 and the 9 make a fraction that's in the linear scale factor. The 12 and the whatever we're trying to find out right here are in the volume scale factor. Now, to set these fractions equal to each other, we have to understand how to do that. In this case here, we have a linear scale factor and a volume scale factor that we're working with. The only way you can make them equal is you either cube the linear scale factor or cube root the volume scale factor. The way you decide is whichever one has numbers in both the two parts of the fraction, that's the one you're going to adjust. So we're going to do this one right here. We're going to cube the 3 and we're going to cube the 9. And now we can set those fractions equal to each other. And then to solve this, we'll just cross multiply. We'll take 9 cubed times 12 and then divide by 3 cubed, and our answer for x is going to equal 324 units cubed. Another important thing to consider is when we're talking about weights, the weight of items, whatever the objects are that are similar, they need to be set up within the volume scale factor. So you'd be making your fractions over here with any kind of weights that are given to you. Now let's look at identifying 3D nets that are possible. When doing questions like this, count the number of faces that you see on the prism and make sure that they match up to the same number that you see here. Sometimes you might have more triangles or more of one shape than you should have, or not enough. Be considerate of those ideas. Another thing is also, will sides end up overlapping? If you were to fold this triangle in right here with this triangle in right here, this triangle would create a problem. Therefore, this would not be considered as one of our possible nets. Look for shapes that would not go together well. This is one of the examples of things that would overlap. Now let's look at 3D cube arrangements. What you want to do when you start these questions is to first of all fill in the mat plan. Take the number of cubes that you see in the picture, write them down as you see in the picture, and then find the largest number off of each column. That tells you how many front faces that you have. Doing that for all three, then find out your largest number in each row. That tells you the number of right faces that you have. Then to find your tops that you have here, you're going to add up anything that has a non-zero number in it, which is these 7 numbers right here, which tells you that you have 7 tops. Then when you take these numbers, the 8, the 7, and the 6, and add those up and double that, that'll be your total surface area. If you want to find the volume, it's very simple. Just add up all the numbers in the mat plan, and that's your answer to the volume. Another situation to consider is when you have a dip in your mat plan. In this case, in this example here, if it goes 3, 1, 2, you're supposed to take the largest number of the column, which is a 3, but when it goes down, that's good, but when it goes back up, that difference of what it goes up by, in this case it goes back up 1, that needs to be added to the total. That's why I have a 4 here. And if I were to do the rest of these, the 5 goes down, that's fine. The numbers go down, that's fine, so it'd be 5 the largest. 6 is the largest here. If it's in the middle, that's fine too. It can trickle down on both sides. 6 is the largest number in this one. But again, if you go across the rows, the 5 is fine. The 6 is fine going this way, that's fine. But this case here, 4 is your largest, and then when you count down, it goes to 1, that's fine. But when it goes back up again, there's a dip of up 1 again. So you have 4 plus the change in the difference of the dip there, and you got 5 total then for this one here. Then if I add up my right sides, my front sides, and my tops, and double that, I will have the correct surface area for a problem like this. What I would encourage you to do right now is to pause the video and try to do this question on your own first. But I will work it out right now. Here we go. For starters, when you look at this problem, you have to notice that they're cylinders. So volume equals pi r squared times the height. That's the formula. Then when we take the information you're given a radius of 2 and a height of 5. So therefore, my volume of this one glass would be pi times 2 squared times my height of 5. Then, if I multiply out 2 squared times 5, that equals 20. So my volume of one glass is going to be 20 pi. Notice I have 3 glasses total, so that's going to be times 3, which gives me 60 pi. That's the volume of those 3 glasses filled to the top, which we're then going to pour into this other larger cylinder, and now we're going to try to figure out how high is this going to get, okay? So if I take the volume again of a cylinder, which is pi r squared, times the height, and I take my 60 pi that I have here and put it in place of that, because I'm pouring the volume, it'll be the same in both, I'll have then 60 pi equals pi times my radius of 10, so 10 squared times the height. Now the main reason I'm working this problem out is because it's how students calculate this from here. First of all, that 10 squared pi turns into 100 pi times h equals 60 pi. Now, to cancel the actual 100 pi, it's how people put it in their calculator that messes this up sometimes for some people. When I divide by 100 pi, this will cross out, and I divide by 100 pi here. Some people will type in their calculator 60 pi and then hit the slash divided by 100 pi, and it won't work. It's because it's very important that you use parentheses around whatever it is you're dividing by. If there's two things, 100 and the pi, then you will get it correct. Next, when you finish solving this, you should get 0.6 as your answer, inches. Hopefully you got that also. And for our last target to make sure you know how to do is finding the area of a polygon. Either you'll start with the radius, the apothem length, or the side length of the polygon, and you'll need to make sure you know how to find the area of a polygon. However many sides it has, you're just going to take the number of sides and divide it into 360. So for this example, you'd have 72 degrees for your central angle. And then you take that central angle that you're given of that triangle, cut it into half, and work with a right triangle. If you can take and find the x value, this length right here, and this y value right here, and multiply those together, you'll have the area of one of these little triangles. Then times the number of sides will give you the final area of the entire shape. Remember to review your SOHCAHTOA skills to find opposite, adjacent, and hypotenuse relationships, and that should be it. Good luck on the test, and I hope this helps.